is Isaac Leyva, and I'm going to show the Bronson-Lowry reaction of these two molecules. First thing is to label the acid and base on the left side of the reaction. To do this, we need to know two things. First, the Bronson-Lowry acid is a proton donor, whereas a Bronson-Lowry base is a proton attacker. And comparing these two molecules, the protons over here are more readily accessible on this side, so this is a likely proton donor, whereas this molecule here only has two hydrogens and a lone pair, which makes it likely to be a proton attacker. So I'm going to label it as such. This is going to be a Bronson-Lowry base, and this is a Bronson-Lowry acid. The next is to draw the curved arrows, and I'll show the products after that. Now, I would have gone with chlorine. However, chlorine is more electronegative than nitrogen, and it's already have a filled octet. So it does not need to share any electrons with any other atom. So we're going to attack this lone pair to this hydrogen and at the same time move the sigma bond over to the carbon. The result will show as this. Because the nitrogen gained a proton, it is now positively charged. And because the carbon lost an electron, or a proton, it is now negatively charged. The next step is to label the conjugate acid and the conjugate base on the product side. Because this gained a proton, this is now the conjugate acid. And since this donated a proton, this is now the conjugate base. Next is to ID the strong acid, the weak acid, and the strong base and the weak base in this reaction using ARIO, or atom resonance induction, and orbital. We're going to see that atom actually works well in this reaction because the nitrogen-hydrogen bond is the nitrogen is more electronegative than the hydrogen, whereas the carbon is not as electronegative than hydrogen. And so it's not really ready to donate a proton. And so this will be a weak acid, whereas this will be a strong base since it wants to, the nitrogen wants to fill the octet. Over here we have a weak base, or a strong base, and this will be a strong acid and a weak base. Now we need to decide which acid would have a higher pKa value. The functional group in the reactant side is the benzylic hydrogen, and its pKa value is equal to 41, whereas the pKa value for the ammonium ion hydrogen function group is the pKa of about 9 to 10. Because the pKa is lower on this side than on this side, the equilibrium will shift to the reactant side because a reaction favors the side with the highest pKa. Because it favors the reactants, these two species will be more present at equilibrium, where the equilibrium constant will be less than 1. Thank you for your time.